All right, guys, let's go over the process of erythropoiesis. Erythro means red, poiesis means to make, and in the second it takes to say that word, you just made 2 million red blood cells, or erythrocytes. It involves the kidney, the liver, the small intestine, and the bone marrow. And it starts when our body gets a little low on oxygen, called hypoxia. That's going to activate some transcription factors in our kidney and our liver. In the kidney, the low blood oxygen activates hypoxia-inducible factor. That's a transcription factor, so it binds directly to the DNA and transcribes a protein, in this case, a hormone called erythropoietin. Erythropoietin is what's going to cause a stem cell to turn into a red blood cell in your bone marrow. But we'll get here in a second. In the liver, the low blood oxygen is going to activate hypoxia-inducible factor and something called high iron, HFE. High iron and hypoxia-inducible factor together are going to inhibit hepcidin. Hepcidin is a protective hormone that we have, and it sounds like an antibiotic, right? Amoxicillin, penicillin, hepcidin, because it is. It's like a natural antibiotic that we have to protect us from bacteria. It protects us by hiding our iron. If we had iron just free in our body all the time, then the bacteria would use it to multiply out of control, and our immune system wouldn't be able to keep up. So most of the time we keep it hidden in our liver and in big immune cells called macrophages. And when you hide something, we call that sequestering. And so it sequesters it or hides it. That way the bacteria can't get it. But sometimes we need iron, like when we need to make red blood cells, because we need it to make hemoglobin. So they're going to inhibit hepcidin temporarily. So that's going to do two things. It's going to free the iron up that was sequestered in the liver and the macrophages. It's also going to open up the cells lining our small intestine to absorb iron from our diet. So let's come over here to our small intestine. In the small intestine, 3 things are absorbed that we need. It's like the 3 ingredients to make a red blood cell, right? So first of all, we're going to need vitamin B12. Remember, vitamin B12 is a very large, complex vitamin. We can't absorb it without the help of intrinsic factor. Our stomach cells make intrinsic factor when we eat protein. So the intrinsic factor helps us absorb vitamin B12, which travels and attaches to erythropoietin together at the stem cell. Erythropoietin cannot bind without vitamin B12. That's going to stimulate the stem cell to turn into an immature blood cell called an erythroblast. It's not mature yet, it's immature. It needs hemoglobin. Remember, hemoglobin is the protein that contains 4 iron subunits. Each red blood cell has 250 million hemoglobin proteins. Multiply that times 4 iron each. That's a lot of iron. So when the iron is coming, that got freed up from our liver and our macrophages and our small intestine, it's going to travel in the blood. But remember from chemistry, iron is very reactive. It's going to react with the cells of our body and cause damage. So we have a special protein that transports it, almost like escorting it. Almost like it's in handcuffs, right? Because it's so reactive and dangerous. It's called transferrin. I have it spelled out here. Trans for transport, ferrin for iron. It's going to hold on, each transferrin holds on to 2 iron and transports it to the erythroblast, and it fills up with hemoglobin. It makes all that hemoglobin. The last thing that it needs to become a mature red blood cell is folic acid. Our small intestine absorbs folic acid from our diet, and that is going to go help eject the nucleus, and that is the last step to make a mature erythrocyte or red blood cell.